Now we have Richard from Brytlyt.
Hi, my name's Richard Heyns. I'm the CEO and founder of Brytlyt, and we are developing the next generation of database. So this is going to be quite a technical presentation. Stick with me, not all of it is technical. Our main product, Makulu, is scalable and affordable and promotes rapid development, which is very important, we believe. So in the early 1800s, the Industrial Revolution was in full swing. And technologies were emerging that allowed people and workers to be far more productive than they had been in the past. And this had a fantastic impact, particularly in the textile industry of the time, and led to the Luddites smashing the looms. Today, a similar revolution is in place. Technologies are allowing companies to innovate and develop products at a fantastic pace using data. And data processing is a very important component of that. Every application that is developed in this space requires a data platform, and the right tool can make a big difference to that. The power of rapid development tools is immense. It allows you to shorten your minimum viable product cycle, and that will allow you to get more product sooner to your customers, which will allow you to respond to feedback faster, and you can gain traction in the marketplace quicker. So what is in the technology stack of a typical application? The foundation is the database, and that's what my presentation tonight is going to be more about. And on top of that, you have the application layer, and that's where all the smart innovation is happening. And then on top of that, you have a presentation layer which allows users to interact with the application and the data. So if we have a look at the database technologies that are available, there are basically three main families of database technology. There's the SQL databases, and these are the ones that we all know very well. They've been around for a long time, from the 1960s, and that's your Oracle and Microsoft. There are NoSQL databases, and they emerged around about 8 years ago from search engines, and then recently new SQL databases have emerged, and they've come about in the last 2 years. And they combine the strengths of SQL with the strengths of NoSQL. So if we have a look at each of those three families of databases in a bit more depth, the SQL databases have some very attractive attributes, and they fall down in some other attributes. So they are based on a structured approach to storing data. They are very fast. They are ACID compliant, which means they have a data integrity guarantee, and they have a longevity. So they are still very successful and very good at what they do. However, they do not handle unstructured data very well, and they don't scale very well, and they can be prohibitively expensive. That brings us to the NoSQL class of databases. They use a slightly different approach to how they store data. It's in unstructured format, and a lot of people use this use JSON to take advantage of this. They're scalable though, and that's an attractive attribute to a lot of sites that want to grow and expand quickly. They've got a low technical barrier to entry, and very importantly, they're free, and that's a very compelling business argument. However, it doesn't go all their way. They are inefficient, and this can be solved by adding more hardware, but there's an expense related to adding more hardware. And they are notoriously hard to develop against, so there's a big development cost when you use these kinds of technologies. They're slow when it comes to running analytics, and they don't have guarantees on data consistency. Which brings us to NewSQL, and this is the class of database that our product Makulu fits under. They emerged in the last 2 years, and they combine the best attributes of a SQL database with the best attributes from a NoSQL database. So the first thing is they're very fast, and they're very scalable. They support structured and semi-structured data, and this is important because a lot of applications rely on JSON. They use JSON in their application layer, and NewSQL databases support that. Importantly, they provide rapid development, so your time to market is reduced and you're able to develop more at a reduced cost. They support ACID, which is a data guarantee, and they are highly available and, importantly, affordable. So these slides are probably a bit technical for general interest here. They're probably going to bore you, but NewSQL's databases are fantastically scalable because they can use a lot of machines in a cluster that allows you to scale out the amount of data you're using very easily and efficiently. And it also means you can have high throughput with write and reads. They also offer fantastic performance, and again, this is based on the massively parallel processing architecture that they're based on. They can be up to 50 times faster than a NoSQL database, and there's at least one instance I know of where a 400-node cluster running Hive has been replaced by a 4-node SQL database. They're ACID compliant, and really all this is about is a data consistency guarantee, and this is important in applications where the application writes data to the database, but that data isn't immediately available to the application. So it'll write, but the read isn't immediately available. And they support semi-structured data. So JSON is a really important component when you're developing applications. A lot of applications today rely on JSON in the communications layer, as do the visualization parts. And the ability to support JSON natively within NewSQL databases is a fundamental component of being able to develop rapidly on this kind of a platform. And rapid development is a really key component of our product. We believe it's the most important component of our offering because it allows you to get your product in front of the customers and iterate the MVP in a reduced time frame. So why does rapid development really matter? Well, if you think about the cost associated with developing a database and an application, if you can halve that cost or halve the time it takes to develop something, that means you can not only save costs, you don't need to, the cost associated with developing an application is greatly reduced, but it also means the time to develop and get your product in front of customers so that it can give you feedback is greatly reduced, and that means that you can progress the development faster, get to a product that is attractive to clients sooner, grow your product and your market share and gain traction in a shorter time frame. Finally, there's affordability, and when you're evaluating a technical platform, there's a couple of components relating to cost and how one goes about associating the cost to taking or choosing a particular platform. Software has a cost, hardware has a cost. I've spoken a bit about development and rapid development. There's a cost associated with that. And also there are the benefits of being able to get your product developed and out to market sooner. To start with, the NoSQL databases are free, and that's a very compelling business case. It's difficult to argue with free product, but a technology platform relies on more than just the software. It relies on the hardware too. And NewSQL databases are far more efficient than NoSQL. They make better use of their hardware, and that means that the amount of hardware that you need to support a specific application on a NewSQL database is a lot less, and that starts to impact the total cost of the platform. But the greatest cost associated with any project, with any application, is the development cost. It far overshadows the costs that you would incur from buying software licenses or deploying hardware. And it is the ability to rapidly develop and reduce that development effort and that cost that is really attractive about our product, our new SQL database, Makulu. So Makulu is based in the cloud. It's a new SQL database that supports rapid development. It's simply licensed, 30% of the hardware cost, And for £39, you can get up and running and start using our technology. And it's a monthly subscription. That's it, no, that's it. That's the end of it. Yeah. Yeah, that's the end of the slide. Yeah.
Questions for Richard?
For sort of a standard startup firm, what's kind of, say, I'm working with some legacy database as well. What's the sort of transition time or effort that goes into transition?
That's a very good question. A lot of the people that I've spoken to have said to me, Richard, fantastic, I love your product. I've just spent the last year, in fact, our dev team just cut their first version last month. I'm already on MongoDB or Elasticsearch or whatever. Now, because it's a rapid development environment, transitioning is actually easier, a lot easier than you expect. What people have come from is a NoSQL environment where the dev cost and effort is fantastic, and they think they're going to have to replicate that. I would say you're looking at a quarter of the time, if not less, quarter of the cost. The other thing is, if you've already started using a platform, every day that you're using that platform, you're going to be less efficient. You're going to be paying more for hardware. Your dev effort is going to be increased. The sooner you can make the transition to a platform that will allow you rapid development, the sooner you can start to realize those costs.
And what if, what if it's from a SQL, legacy SQL environment?
It's fantastically easy to do that. The front end is Postgres, which is very similar to Oracle's interface, and there are companies that will port Oracle code to Postgres, so you could do that in an incredibly short time. But other SQL databases, it's very similar to SQL. It is SQL. It's Postgres version of SQL. So we have data connectors, so we can very easily connect and even stand alongside existing infrastructure and technologies.
So in terms of migrating a procedure, like a complex or procedure-based operation, what would be the difference?
Postgres store procedures are implemented as functions. So what you would do is, one would need to look at the business case and the function and the data structures and what the store procedure is doing. But if it's a SQL database you're porting from, it's incredibly easy. Do you agree?
No, yeah.
Sorry, there's somebody behind you nodding his head.
No, I would
So we got some agreement in the audience. Fantastic way. SQL databases and Postgres is a SQL database, so you would literally just copy the tables in and rewrite the stored procedure, and you got some source code to look at. It would be incredibly easy.
Okay, great, thank you.
This is actually a quite nice and compelling proposition, but I have two questions. Who are your competitors? Because recently, for instance, Microsoft released DocumentDB on Azure. And this is something like they have SQL, they are on cloud, kind of NoSQL, SQL, something in between. And second one, how do you educate your customers use it? Because for instance, like this is something new, or for instance, can I come with my NoSQL and SQL background and start using your software instantly?
That's a very good question. So there's two parts to that question. Our competition are people are using NoSQL providers and SQL providers who are very cost competitive. So there's a couple of people in that space already. You've mentioned Microsoft on Azure. Redshift on Amazon is another competitor. Those are the people we are competing against. It is a competitive environment, but we feel that the licensing model that we're adopting is very competitive in that space. We've done a lot of research on Amazon and the other providers in that space, and this actually competes very well against them. The second part is educating users on how easy is the platform to use. So it's based on Postgres. So any Postgres developer will be able to immediately use the platform to its full potential using their current skill set and knowledge base.
What about tools? Do you have your own tools, or we can use Postgres tools?
So at the front end we have adopted is PG Admin, which is the Postgres standard for interfacing with a Postgres database. We've got some standard tools and connectors that allow you to connect to legacy systems like Oracle and SQL, flat files, streams. We've got a Hadoop connector, so we can come alongside companies that have an investment in NoSQL already. And the interesting thing about that is you can then leverage people with SQL or developers with SQL skills. They can immediately start to gain traction using our platform, interrogating a NoSQL database. So there's a very low hurdle to entry for SQL developers on this platform.
Okay, thank you.
Why Makulu? What does Makulu mean?
That's a very good question. I'm from South Africa, and Makulu is big in Zulu.
Hi. Yeah, I just wondered if you could kind of help me with a mental model for the NewSQL database, because I kind of understand a NoSQL database being a bit like a kind of very large Excel spreadsheet with lots of nice orderly values, whereas NoSQL by comparison is more like a woman's handbag that might have, you know, some photographs, some digital currency, a spare pair of knickers, a lipstick, all kinds of this thing. So what's the kind of mental model for a NewSQL database? How does that compare to those two mental models, if either of them are even right?
So that's probably quite a good analogy. I think there's a couple of things that one would want to sort of bring into a response to that. The first is people are generally using NoSQL databases in a semi-structured way. So we would not be able to support a totally unstructured use case, but we do support very well applications that are using NoSQL in a semi-structured way. So they're storing a lot of data in JSON documents, and JSON's a very cool technology for doing that because it has a hierarchy and a bunch of attributes around it. So that's the NoSQL, and it scales very well. A NoSQL database. The things that are not so cool about a NoSQL database is it's not designed for performance or speed. So there's a hardware factor, and they are very difficult to develop against. They're not a very mature environment. So they scale. They support JSON in a native way, which is what application developers enjoy. On a SQL side, very structured. But because they're so structured, you don't really get that flexibility that JSON allows you. So we support a native JSON data type, so you can store JSON in a table. You can take some of the attributes out, put them in a column, index them. You've got a key value store there. And we're also able to scale. So SQL databases, unless there aren't a lot, I don't know of any scalable SQL databases that are affordable. You're looking at quite an investment in software.
So it works perhaps a little bit like a coding framework, like Rails for Ruby then. It gives you a kind of a structured way of using a NoSQL database. Is that a way of thinking about it?
If you can maybe think of it as a semi-structured database. Okay. And the fact that you're not going all the way down, all the way across to one side where you've got unstructured, and you're not limited by a structured database. You're sort of sitting in the middle. You get the flexibility that an unstructured database gives you when you use it in a semi-structured way, and the performance of a SQL database and the rapid development capabilities of a SQL database. SQL is a far easier technology to develop against. You can get products and do constructive work in a far shorter time frame.
Just a quick one. What's the differentiator between Makulu and other NewSQL providers?
That's a very good question. There are a couple of other NewSQL providers. MemSQL is one of them. They're typically in-memory databases, and they are going to be expensive. And they typically also have a proprietary flavor of SQL. They are not as well developed. They may or may not give you data consistency, asset compliance. So part of it is cost, part of it is the Postgres front end. We also have a second product that's in development, Makulu Extreme, which is based on GPUs, and that is very much positioned at a pure performance space.
What's the exit plan?
The route has several exit plans. So we're looking for funding. We've got $1 million. We're looking for $1 million of EIS funding at the moment to progress Makulu Extreme. And the first route of exit is when we go for a Series B funding. That will give an opportunity for early investors to exit if they want to. We've spoken to several organizations that can facilitate that kind of arrangement. So that's at the 2 to 3 year mark. And then at the 5 to 6 year mark, we're considering either a market sale or IPO.
Richard, thank you very much. Thank you.
Thank you.
Very good. Very good. Very good. Very good.